Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today inshallah we will discuss about the cyclic group, very important topic of group theory. Cyclic group in group theory. Let's start the lecture. Cyclic group. A group is said to be cyclic if and only if it is generated by a single element. If any group is generated by the single element, it is called cyclic group. It means that all the elements of that group can be generated by a single element, then that element is the generator of group, and that is called cyclic group. A group generated by A such that A raised to power n is equal to identity, and its nth power means that number of elements are n also equal to number of n. So n means it contains these elements, and its last power give us identity. For example, by example you can easily understand. For example, a group G is equal to 1, minus 1, iota and minus iota. Here the generator of G is iota and minus iota as well. As we know that iota raised to power 1 is equal to iota. Iota raised to power 2 is equal to minus 1. And iota raised to power 3 is equal to minus 1, because iota square is equal to minus 1, and one more iota give us minus iota. Iota raised to power 4 give us 1. So it create whole group plus 1, minus iota and iota. All the elements of that group are generated by only iota. Here we see iota is the generator of all elements of G, and minus iota raised to power 1 give us minus iota. Minus iota raised to power 2, minus is cancelled by the square, and iota square is equal to minus 1, and minus iota raised to power 3 give us plus iota, and minus iota raised to power 4 give us plus 1. So 4 elements completed. 1 is identity here, iota minus iota and minus 1. This group is generated by iota and minus iota both. Here we see that iota and minus iota are also inverses of each other. Very important thing here, that it means that the element that generates the complete group, its inverse also can generate the complete group, because iota and minus iota are inverses, because when we multiply iota by minus iota, it's give us identity element, that is 1 here. So it's mean that we have a statement here, we concluded a statement here. If an element of G is the generator of G, then its inverse is also generator of G. If an element of G is the generator of G, then its inverse also generator of G. Let's see some more examples of cyclic group. These examples we have discussed. Z5 with modulo Z5 mean with modulo 5 with respect to addition. Modulo addition is a cyclic group when we here every element is generator. Since every element of 5 is in the power of single element, that is 1, therefore 1 is the generator of Z5. Sorry to say, 1 is the generator of here. When we add 1 in all the elements, let's say 0 plus 1, it gives us 1, the one element, and 1 plus 1, it gives us 2, 2 is element here, and 1 plus 1, it gives us, 2 plus 1 is give us 3, 3 is here, and 4 plus 1, 3 plus 1, it gives us 4, that is here, and 4 plus 1, that is equal to 5. As we taking Z5, the 5 has no remainder, that's why its remainder is 0, so 0 element is also here. In this way, the 1 generates its complete group. The 1 and minus 1 is a cyclic group under the multiplication. So you will find the generator of 1 and minus 1. What would be the generator of 1 and minus 1 with respect to multiplication? Very easy to understand. Here minus 1 is generator. When we take the power of minus 1, 1 that it give us minus 1, that is here. And when we take the power of minus 1, 2, minus 1 raised to power 2, it give us plus 1, that is here. Like that, when we take its power 3, it give us minus 1, plus 1, minus 1, plus 1. So here minus 1 is generator. Here the lecture ends. I hope you understood. Thank you so much.